This video is going to be about adding and subtracting polynomials. So at first here we've got an example which is 2x squared minus 5x plus 11 plus negative 3x squared negative 2x negative 7. So when we're talking about polynomials, we've got these are both trinomials, right? Trinomials have 3 terms. So the first polynomial there has 3 terms and the second polynomial has 3 terms. The other words we use are binomial if it has 2 terms and monomial if it has 1 term. So these are both trinomials, and we can do this with or without modeling. I'm going to show you just a visual model to go with these polynomials. So we can use algebra tiles to model these. So we've got x squareds are the large green x's. X's are just the sort of skinny green ones, and then the ones are the little red ones. So we're using the colorful side, so either the green or the red as positive and the white side as negative. So the first thing I'm going to do is just draw all of these polynomials. Okay, so there we go. So that's what this would look like. We have 2 positive x squareds, we have 5 negative x's, we have 11 positive 1's, then we have 3 negative x squareds, 2 negative x's, and 7 negative 1's. When we're adding, we just want to combine what are called like terms. That means things that are the same type of tile. So we're going to put all of those together. Then we need to evaluate whether we can make any zero pairs. So a zero pair involves a positive and a negative, and together they make 0. So if we look, we can, right? We have 2 positive x squareds that can go with 2 negative x squareds to make 0 and leave us with 1 negative x squared. And then over on the 1's, we can make some 0 pairs there as well. Notice that we can't make 0 pairs with the x's because they're all negative. So we can't make 0 pairs unless they're the opposite sign. Now what we need to do is write out what we've got left symbolically. So we've got 1 negative x squared, we have 7 negative x's, and we have 4 positive 1's. So we've got negative x squared, negative, take away 7x plus 4. You'll notice that we don't need to write 1 in the coefficient, but it's not wrong. So if you started with negative 1x squared, that's also correct. For our next example, we're going to subtract these same polynomials. So when we're subtracting polynomials, we can sort of come at it from a few different strategies, but what I find works pretty consistently is instead of trying to subtract, because sometimes we get a little mixed up with like negatives and positives and we can get a little confused there, what can work well is instead of subtracting, we change it to adding, and then we flip over everything in the second polynomial. So that's what we're going to do. We're going to change our subtracting to adding, and then flip the second polynomial. So when we flip the second polynomial, symbolically what we've done is we've switched the sign of everything in the second polynomial. Very important that the first polynomial should remain the same. Then we're going to try to do the same thing, which is combine like terms. And again, I'm doing it pictorially, but you can also do it symbolically. We're just trying to make sure that we're only combining like terms, right? So the x squareds go together, but they wouldn't go with the x's or with the 1's. So we've put everything the same together, all the like terms together, and then we're looking for 0 pairs. So our 0 pairs need to be positive and negative together. The only place where we see that happening is in the middle with the x's. So we're going to make 2 0 pairs there. Once we made our 0 pairs, all that we have left to do is write the answer symbolically. So we have 5 x squared tiles, we have 3 negative x tiles, and we have 18 1's tiles. So when we have 2x squared minus 5x plus 11, subtract negative 3x squared, take away 2x, take away 7, we get 5x squared minus 3x plus 18.